Physical properties. What is a property? A property is a description of an object. If struck by lightning, the tree could catch on fire or burn. The tree is tall. The tree is green. All of these are properties that describe the tree. Okay, so we're looking at things that are describing the tree. But then we have two different types of properties. We have what is called a physical property, and then we have a chemical property. Physical properties are determined by the use of the 5 senses. They are a description of an object. So what are your 5 senses? Well, we have sight, taste, sound, touch, and smell. These are the 5 different senses that we use in order to describe physical properties. If at any time you need to pause this recording to get your notes, please do so. So let's look at some examples of physical properties. Color. There is blue, red, green, yellow. These are colors, and they are done by our sight, our sense of sight, so it is a physical property. Smell. The dinner smells sweet. Well, that is one of our senses, so that would be a physical property. Taste. The cookie tastes salty. That is a taste done by one of our 5 senses, so it is a physical property. Hardness. The wood is hard. That is another physical property because we can tell that it is by our touch. States of matter. Is it a liquid? Is it a gas? Is it a solid? Is it plasma? Those states of matter are also considered physical properties. Is something boiling, freezing, or at a melting point? All of these are examples of physical properties. Again, if you need to pause this to take notes, please do. What are some more examples of physical properties? Density. We learned about density in the last exploration. How dense is the material? The more compact the matter is on the inside, the molecules, the more dense it is. That would be a physical property. Mass. How much of an object there is. That is a physical property as well. Volume. How much space does it take up? That is a physical property. And then here's a new vocabulary word. The vocabulary word is malleable, malleability, or malleable. This is the ability to be molded. So like a clay that this person is touching and molding into a pot, that would be said that that clay is malleable, or it has a malleability to it. That is also a physical property. Solubility is another new vocabulary word. Solubility is the ability to be dissolved. Can it be dissolved easily? Can it be dissolved completely within a water or some type of a liquid? Those are physical properties as well. If you need to pause, go ahead. So what is a chemical property? We looked at physical property, and that's the 5 senses, anything that deals with 5 senses. Chemical properties are a little bit different. They are determined by a substance's ability to react with other substances. All right, and that's kind of the reaction we get when we put baking soda and vinegar together and we get a reaction. Well, that is actually a chemical reaction or property. Examines examples of chemical properties. The ability to react with air is definitely a chemical property. Some of the ways that words that go along with reaction to air are rust. Iron rusts with air. Tarnish. Silver will tarnish when exposed to air. Corrode. You can see corrosion on vehicles that when you introduce salt and water to a metal, we can get a corrode or corrosion. And rot. And rot is when you mix air and moisture with wood or paper. That can rot, and I'm sure you've seen that out in the woods if you've walked around the woods at all. It's the ability to react with water or acids. That's another way for another example of chemical properties. Water, how something reacts with water or acids. The ability to catch fire or its flammability. That's another new vocabulary word maybe. Flammability is the ability to catch fire. Paper is flammable. It's easy to catch fire. That makes that reaction between heat and the fuel a chemical process. So let's take a look. If we were to look at this, we say the ability of gunpowder catch fire to explode. The ability of gunpowder to catch fire to explode. Is this a physical or a chemical property? Oh. Go ahead and write your answer down on your slide. It actually is a chemical property. Because we're adding fire to the gunpowder, it's changing that gunpowder and it is expelling its energy. So the ability to catch gunpowder on fire to explode is a chemical property. Let's look at another. Physical or chemical property. The color of a sunset. So if we were to take a look at the sunset, is this a chemical property or a physical property? Write your answer on your paper. Well, because we can observe it with one of our 5 senses, this is technically a physical property. Chemical or physical? The ability of a nail to rust. Is that a chemical property or a physical property? Well, because rust is a reaction between iron or metal and air and water, this is a chemical property. Physical or chemical? The shape of a leaf. Please write your answer in your notebook. Because we're only dealing with the shape of a leaf, this is a physical property. The ability of wood to burn. Is that physical or chemical? Write your answer in your notebook. Because the wood is reacting to heat and oxygen, and it's changing its form, and it's going to become ash, this actually is a chemical property. Because the wood is technically changing forms. Physical or chemical property. The hardness of a diamond. Please write your answer on your sheet. Because we're dealing with one of our five senses to look at this property or this characteristic, this is a physical property. Physical or chemical property, the volume of your Coke. Write your answer down. And because it's dealing with volume, and volume is a physical property. Physical or chemical property, the mass of 2 camels. Because we're dealing with mass, and mass is measurable, it is a physical property. So let's look at physical changes. A change that occurs without changing the identity of a substance. That is a physical change. No new substances are formed. So even though you might cut your hair, does your hair actually change its identity or change its object? It doesn't. If you cut your hair, what's laying on the floor is still hair. So there's no new substance formed. If you were to take peanuts and crush them and grind them into peanut butter, have we made a new substance? Technically, no, we haven't got a new substance. All we have is the changed form, physical form of the peanuts. If we were to look at it under a microscope or in its DNA, it would still be a peanut. So physical changes occur without changing the identity of the substance. No new substance formed. If you need to take notes, you can pause this. So examples of physical change. It can be a change in your size, shape, or color. So examples are pencil shavings, torn paper, crushed ice, sugar dissolved in water, painting a wall. All of these are examples of physical change. Sugar dissolving in water, if we were to evaporate all of the water, we would still have sugar crystals at the bottom of the glass. That's why sugar being dissolved in water is still a physical change. A chemical change that occurs. So what is a chemical change? Well, it's a change that occurs that causes the identity of a substance to change. Something is new, something new is formed. New substances with new properties are formed. So a chemical change is anything that causes the identity of the substance to change. So when you you expose wood to heat and oxygen, it creates fire. Well, that fire is a chemical change because that wood, once it starts to be burned, is no longer wood anymore. It turns into ash or carbon. And that's a chemical change. So, evidence of a physical change. How do we know we have a physical change? Well, new colors can appear. Bubble or fizzing. If you add something together with water and it bubbles or fizzes, or if you add something with another, say baking soda with vinegar, we get bubbles or fizzing. All right? That is a chemical change. Precipitate forms, meaning solid material. So does the material change? If you were to add water and cornstarch together, it actually precipitates a form. It creates a solid. Is heat produced? Does it create heat? That is a chemical change. Light. Is there light produced? In order for light to happen, when you combine elements or combine objects, there is some kind of a chemical change that's going on. Sound. Does it make a sound? Have you ever listened to when you add baking soda and vinegar together? It makes a sound. When you introduce heat and oxygen to wood, it creates a sound, a crackling sound. When you strike a match on sandpaper and it starts to burn, you absolutely hear that sound of the fire igniting. Those are chemical changes. Or is it difficult or impossible to reverse? Ready? Once you strike that match, it's hard to reverse and take it back. If you add baking soda and vinegar together, you can't separate the two out. If you go and you try to make wood out of the fire, oxygen, and fuel, if you try to do that again, you're not going to be able to do that because you can't take that back. So a chemical change is something that you can't take back. You can't unmake it. If you need to pause, go ahead. So what are some chemical changes? Well, vinegar and baking soda, that is a chemical reaction, and it's the release of carbon dioxide gas. Another one is called oxidation. Oxidation is when iron and oxygen come together and form rust. That is a form of a chemical reaction. A reaction with electricity. You can use different substances and you can add electricity to it and you get stuff like silver plating, gold plating. That's a chemical reaction as well, a chemical change. Sodium plus chloride equals salt, and that's your table salt. If you add silver and sulfur that's in the air, we get what is called a tarnish. These are chemical changes. Other examples: wood burning, metal rusting, food digesting, gasoline burning, cakes baking. All of these are forms of chemical reactions or chemical changes. So we're going to talk about each one of these. You have 2 on your paper, but for me, I have a new slide for each one. Water evaporates from the ocean. Is that a physical or a chemical change? Please write your answer in your notes. Well, water evaporating is technically a physical change. Water is water, regardless if it's H2O, regardless if it's in vapor form, in frozen form, or in water liquid form. It is just a physical aspect. Physical or chemical change. The yolk of an egg, which contains sulfur, causes tarnish to form on silver. Is that a chemical or a physical change? Please write your answer down in your notebook. Well, because it's causing tarnish, this is a chemical change. The ice on a lake melts and becomes water in the lake. Is that a physical or a chemical change? Write your answer in the notebook, please. Well, because all that ice is technically water, and it's entering into the lake, this is just a physical change from one state to another state of matter. Charcoal in a fire turns to ash after several hours. Please write your answer in your notebook. Because you are adding oxygen and air in with the fuel of the charcoal, and the charcoal will never be the same again, this is a chemical change. Physical or chemical change. A pencil is sharpened in a pencil sharpener, leaving behind shavings. Is this a physical or a chemical change? Write your answers in your notebook. Because all that's happening is that the pencil is getting shorter and it's leaving behind the wood shavings, this is a physical change. A battery makes electricity to turn on a flashlight. Is this physical or chemical? Write it in your notebook, please. This is a physical change. All that it has done is take the stored energy that's in the battery and it's now just changed its form. So it is a physical change. A bicycle rusts when left in the rain. Is this a physical or a chemical change? Well, because we're dealing with rust and a reaction with the rain or the water from the rain, this is a chemical change. Physical or chemical change. A shirt is accidentally torn in the washing machine. Is this a physical or a chemical change? Please write your answer in your notebook. Because all that happened was that the form of the object was changed because it was torn. This is a physical change. And here's an extra one. A log is split in two by an axe. Because the fact that the log has not changed form, has not turned to ash, it hasn't been burned. This is a physical change as well. There are some notes that I want you to do. It's called doodle notes, and we will go ahead and do that in just a few minutes. Please make sure your notes are completed. Thank you.